Everything in this series works. Fingerprints, shared keys, the handshake between strangers, signatures, certificates, all mathematically sound, none of it broken. And yet systems built from it get broken constantly, almost never because somebody defeated the mathematics. So this last episode is about how cryptography actually fails, which is a far more human story. Failure 1, the most common by far. The key gets left where anybody can find it. A developer in a hurry pastes a private key into their code, and that code ends up in a public repository. Not maliciously, just Friday afternoon. And here is the part people underestimate. Bots scan public code constantly for exactly that shape of text. Keys have been found and abused within seconds of publication, not days, seconds. A code file with a private key visible being pushed to a public repository, bots immediately grabbing it, labeled "found in seconds." And there is a sting. Deleting the line does not fix it, because the old version sits in the project history permanently. The only real fix is to treat that key as burned and replace it. The mathematics was flawless. Somebody left the key under the mat. Failure 2 is subtler. A lot of cryptography quietly depends on numbers being genuinely random and never reused. Pick a fresh, unpredictable value each time and everything holds. Use the same one twice and you can leak the message or, in some systems, the private key itself. Not theoretical. A famous games console was signed using a value meant to be random every time, and the maker used the same fixed number for everything. Researchers noticed, worked backwards, and recovered the master signing key. The mathematics did exactly what it promised. It was fed the same number twice. 2 signatures stamped with the identical random value, an arrow leading to a recovered private key labeled "reused, not random." Failure 3 has a slogan attached. Somebody writes their own encryption instead of using a tested one. And here's what makes it dangerous. It will appear to work. It scrambles and unscrambles perfectly. Every test passes. It looks like success. Because working and secure are different questions, and only one shows up in testing. Normal bugs announce themselves. Something crashes, a customer complains. A cryptographic weakness makes no noise. Everything runs beautifully for 2 years until somebody who knows what to look for reads your code for 10 minutes. A machine scrambling and unscrambling a message with green ticks, a hidden door on its side sitting open, labeled "It works, it is not secure." That is why you hear, "Do not roll your own crypto." It sounds like gatekeeping. It's not. The tested implementations have been attacked in public by specialists for years and patched every time. Your version was reviewed about you on a Thursday. It's not about intelligence. It's about how many people have genuinely tried to break it. Look at the pattern. Nobody attacked the mathematics. In every case, it sat there, working perfectly, while something around it failed. The key was stored badly, the randomness was not random, the implementation was homemade. Cryptography almost never breaks in the middle, it breaks at the edges, where it meets code and people in a hurry. A strong box labeled "mathematics" with 3 cracks around it labeled "stored badly," "not random," and "homemade." So here's the big picture, and the whole series in one thought. The hard part of cryptography was solved decades ago, and it's not the part that fails. What fails is everything wrapped around it. Using cryptography well isn't really a mathematics problem, it's a discipline problem. Keep your keys somewhere real. Never reuse what should be random. Use the boring, battle-scarred implementation thousands have already failed to break. That's the series. Fingerprints, keys, handshakes, signatures, certificates, and the humility to use them well.